Algebra I, 12.4c, graph a quadratic function with the vertex and axis of symmetry. As I said in the last video, if you haven't watched the previous videos, you're going to get lost or confused. So this is the third part. This is C, the third part of lesson 4. So we did A and B, and you need to go into this video's description and click on those links and watch them real quick so you don't get lost, okay? So we have this standard form of a quadratic function. It's y equals ax squared plus bx plus c. You can also see it as the function of x. When we have quadratic functions in this form, we can find the vertex and axis of symmetry by using this little guy. The x-coordinate of the vertex is going to be a negative b divided by 2a. When we plug in our values for our quadratic function for the a and b here, we can find the axis of symmetry as the line x is going to equal this negative b divided by 2a. So let's see how this works. Here we've got an example of a function, a quadratic function, okay? And we've got our color coded. We've got a is red, b is blue, and we're making the x green. So here's our function. We've got a negative x squared plus 2x plus 3. So now you can see what represents what, can't you? This is the coefficient for x squared, and we have a negative here. But since that coefficient of a is a negative, we know our parabola is going to open downward, don't we? We learned that in the last couple of videos. And since this function does have the ending bx plus c back here, see? We know that the vertex may shift from that origin 0, 0. In the last video, we talked about it was only ax squared, and our vertex was on the origin 0, 0, and our axis of symmetry was on the y-line. Now that we've got this back end, it may shift, okay? So the x-coordinate of the vertex is this formula, negative b divided by 2a, and we've got an invisible 1 here, don't we? So it's a negative 1 x squared. So we've got a negative 1 here, a 2 here, and a 3 here, all right? So the a is going to be negative 1, and the b is going to be the 2. Now we just do a little math. 2 times negative 1 is negative 2, but it's already over a negative, isn't it? So this negative 2 over this negative 2 makes a positive 1. So we know the x-coordinate of the vertex is 1. Now we substitute that 1 into the original function and solve for the function of x, which is y. So here we have our equation, our original equation up on the top, okay? We plug in our 1 right here. We've got our negative 1 here, that invisible one. 1 times 1 is 1, times negative 1 is a negative 1. And 2 times 1 is 2. See, we're plugging the 1 in for x. 2 times 1 is 2, and plus 3 is a 5. So now we have negative 1 plus 5. So we know the function of x is 4. We know the vertex is going to be at 1 for x and 4 for y. See? We figured out the x-coordinate. It's a 1. And now we figured out the y-coordinate, the function of x, as 4. We know where to put our vertex when we graph this. So the axis of symmetry is the line x equals 1. It's the entire line. Here's 1 for x. X equals 1. It's the whole entire line. That's our axis of symmetry. That's where our parabola is going to be split in half, just like, hold on, our little heart here. Our little heart has an axis of symmetry coming down the center, and it splits it in half. See? That's what it's going to do to the parabola, but it's going to be where x is 1, all right? So it includes all the values for y, y1, y2, y3, y4, y5, all the way up where x is at the 1, see? Now we can choose points on both sides of the vertex in that axis of symmetry and graph the parabola. And because we have a negative coefficient, we saw that it was a negative, right? We know that our parabola is going to open downwards. Now take a look at what happens if x didn't equal 1. What if x equaled a negative 6? Well, then that means our axis of symmetry would be here on negative 6 for x, and it would go this entire line. And if it came out that the x was equal to 4, then it would be way over here, and then our parabola would either be here or here, see? But it's negative, so it's going to open downward, isn't it? It would be like here or here. So it's shifting over, see? It's translating. So we can do a table of values that will make our equation true, and I came up with these values. So if this is our equation, our function, and we have a -1 times x squared plus 2x plus 3, these values will make the function true if you plug them in. And I didn't want to make a 14-minute video, so trust me, these make the function true, okay? So we know from this table that it gave us ordered pairs, didn't it? So now we can plot these points and do our parabola. And it's facing downwards because we have that negative coefficient for x squared. And we plug all of these points into here, and we have our -1, 0, we have our 0, 3, we have our 1, 4 for our vertex right here. We've got our 2, 3, and we've got our 3, 0. And we can see it's upside down. See that? And the vertex shifted. It translated 1 to the right, away from the y line for x, and it went up 4 for the y value. 1, 2, 3, 4. Because our vertex is at 1, 4. See? So that's where it translated to. That's where it shifted to. All those values make the function true. Okay? Now, look at these two. Compare this pink one to this blue one. I hope you can see the colors. We're going to compare two functions. The vertex shifted, translated k amount of units, okay? Vertically. So it went from here to here, see? If it's a positive k, then it shifts up. If it's a negative k, it shifts down, all right? So it would be as if this -2 was a k, all right? I actually put a real number in, but it could be like a plus or a minus k. And you might see it like that, and it's just representing that variable. And you saw in one of the other videos that it could be the letter C, okay? If we subtract C from both sides, we get a negative. All right, so that's in this equation. If we subtract C from both sides of the equal sign, it could equal a negative C, couldn't it? So if we do x is equal to these values and the function of x squared are these values, so this would be like the x and the y, like this, we would get this dark red parabola. See that? If we had x as these values and the function of x was x squared minus 2, now we have a minus 2 at the end of it, it would make these the output, the range, the y values. And our entire parabola would shift down by 2. So it says minus 2, the parabola goes down by 2. See that? So all quadratic functions, like I mentioned before, all quadratic functions are polynomial equations of the second degree. And they have parabolas as their graph. And they look like this, either up or down. And linear functions are polynomial equations of the first degree. See that? And they make straight lines. So it could say degree 2, it means second degree. It could say degree 1, it means first degree. Okay, you might hear that, especially in Algebra 2. We're getting really close to Algebra 2. So now our next video is 12.5a, and we're going to talk about equations of direct variation. And like always, if you want to go into the description of this video and click on any videos that you missed, in case you were confused about something here, that means you missed a video, okay? So go into the description. Go through the list. If you don't recognize anything, start watching them all, okay? Because somewhere you got lost, all right? It's like climbing 100 steps. You can't skip steps or you're going to fall, okay? I'll see you next video. Bye.